Hey guys, how's it going? All right, so kind of switching in this unit right now. So we're not really necessarily talking about systems of equation right now. The topic we're talking about inequalities right now. So as you go further on in math, you will have to solve inequalities, more and more often. So we're just going to kind of do a bit of review with some inequalities and I'm going to show you how they work. All right, so example 1 is a bit more general over here. So the question says, is this point 2, 1 a solution to A, B, C, D? So just remember here, guys, that this is our x coordinate and this is our y coordinate here. So all I'm going to do for these questions, I'm going to plug them in for x and y and see what we get. So in this case, 2 times 2 minus 1 is 4 minus 1, 3. Well, 3 does in fact equal 3. Okay, so 3 equals 3. So I'm going to say yes, 2, 1 is a solution. Looking forward to B now, same idea. So I'm going to plug in my x and y for 2, 1 into this equation here. So I get 2 times 2 plus 3 times 1 is 4 plus 3, which is 7. Well, 7 does not equal 8. So therefore, this is an incorrect statement over here. So no, 2, 1 is not a solution. All right, so very similar to what we're doing here, but now instead of saying an equal sign, we actually have a greater than sign, okay? So we have y is greater than 2x minus 5. So I'm going to do the same thing. I'm going to plug my x and my y in. So y is 1, 2 times 2 minus 5. This is 1 is greater than, 2 times 2 is 4, minus 5 is negative 1. Well, 1 is greater than negative 1. This is true. So therefore, 2, 1 is a solution. Y is greater than or equal to 5x minus 9. So same thing. 1 is y, greater than or equal to then 5 times 2 minus 9. So we have a 1 is greater than or equal to 5 times 2 is 10 minus 9 is 10 minus 9 is 1. Okay, so 1 is greater than or equal to 1. So yes, 2, 1 is a solution. Okay, so just how it works, like if we're asking for if a point is a solution like that, this is what we're doing. Okay, we're just going to plug that point in and see if the resulting statement is true. So 3 does equal 3, 7 does not equal 8, so it's not a solution. 1 is greater than negative 1, so it is a solution, and 1 is greater than or equal to 1 for this last one, so it is a solution as well. Moving forward, we have y equals 4/5 x minus 3. Okay, so just a little bit of review over here. Remember way back to math 10c. Hopefully this is familiar, but y equals mx plus b. B is the y-intercept, and m is the slope. And I'm going to put in brackets here, m equals rise over run. That's how we calculate slope. So if I have 4/5 x minus 3, that means negative 3 is my y-intercept. So I have a point here. And then this means I'm going up 4 to the right over 5. So I go up 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, do the same thing. I can go down 4, left 5. 1, 2, 3, 4, 1, 2, 3, 4, 5, like this. So the line I'm getting is this guy over here. Okay, now way I show you. So what's this actually? What does this line mean? If I look at any point that's on this line, so say for example 10, 5, this should satisfy this equation over here. Let's just check to make sure it does. Okay, so if I plug in, this is my x, this is my y, I would get 5 equals 4/5 times 10 minus 3. So 5 equals 4/5 times 10 is 40 over 5, which is 8, minus 3. Well, yes, 5 does in fact equal 5. So the point I'm trying to get at is that any point on this line over here is going to satisfy this equation over here. Okay, a little bit different over here. I have y is less than or equal to 4/5 x minus 3. Well, we just did 4/5 x minus 3. It was like this guy over here. And we saw this line. Okay, so I'm just going to do the same thing that I had before. I'm just going to draw this line 4/5 x minus 3. Okay. Now, the idea over here is I'm going to ask a question. Is this point a solution to this inequality over here? Well, this point is like 7, -2. Let's see if this point does work. So if -2 goes in, -2 is less than or equal to 4/5 times 7 minus 3. Okay, well, 4/5 times 7, I'm just going to do this in my calculator quickly. 4/5 times 7 is 5.6 minus 3 is 2.6. Okay, well, is -2 less than or equal to 2.6? Yes, it is. Okay, now the point we're trying to get is we're saying that y is less than this line over here. So really what we're doing is we're counting everything that is shaded in below this line over here as well. Okay, so we're going to be able to see that as well. I'm just going to quickly show up what this is going to look like with my graphing program here. So if I look at my graphing program, and if I go y is less than or equal to 4/5 x minus 3. Okay, well, here's the same line that we saw. So we saw the 4/5 x minus 3 is this line over here. And as you can see, this computer is shading in everything in below it over here. Okay, so that's what this is going to mean to graph this inequality. We have y is less than, so that means we're going to shade in below the line like this. Okay, y is greater than -1/2 x plus 1. So this is a slope of, I'm going to say m equals -1/2 like this. That means we're going down 1/2, and we have a y-intercept of 1. So if I go down 1/2, down 1/2, down 1/2, down 1/2, and same thing, if I can go up 1, left 2, like this, I have these points. Now here's a bit of a difference from this question. So first of all, we're going to do is we're going to kind of figure out what this line looks like. Now what's different here is we want greater but not equal to. So if I want points that are equal to this line, I'd be filling in this line. But if I do a dashed line instead, what this is meaning is that this is a boundary line that we are not including as part of our graph. If I want y is greater, that means I'm going to be shading in above this line like this. Okay, now this does not look great on this program over here. I'm trying to see what this looks like on the better graphing calculator here. So if I wanted to graph this like this, I can go y is greater than -1/2 x and plus 1. Okay, so it's just looking like this, the same way I did. As you can see here, we have the dashed line, which means that this is the boundary line, but we are not including any points on this boundary line. Y is greater, that means we're shading above this line like this. Okay, last one, we have graph 4x minus 3y plus 12 equals 0. Okay, first thing I'm going to do is I'm just going to solve this equation for y, or this inequality for y. So I'm going to add 3y over here. So we get 4x plus 12 is less than or equal to 3y. Okay. Now, next thing, I'm just going to divide everything by 3 like this. And 4/3 x plus 4 is less than or equal to y. I'm just going to flip this around and make it y is greater than or equal to 4/3 x plus 4. So this would look like 4 is my y-intercept here, and I'm going up 4 over 3. 1, 2, 3, 4 over 3. Up 4 over 3. Or I can go down 4, left 3. Down 4, left 3. Okay. Now in this case, we are including the boundary line because it's greater than or equal to. So this is going to be a solid line here. And we want greater than, we're going to shade above the curve like this. Okay, just confirming on our graph. So we want 4x minus 3y plus 12, and this is less than or equal to 0, less than or equal to 0, just like we saw before. So here's our solid line like this, and we're shading above the curve like that. Okay, so you can see this a bit better like this as well. All right, guys, I hope that two variable linear inequalities make sense, and I will see you in the next video. All right, give me one sec here.